Okay, so this is continuing on from my previous video, part 1 of Applications of Polynomial Equations. So we're going to have a look at example 2 here. Again, this is another example where we're given the function and then we want to do things with that. In terms of good CAS use, there's no problems with the history there whatsoever in the CAS, but if you would like to start from a clean slate in your Scratchpad calculator screen, menu 1.5 to clear history. That's going to clear what's happening there over in your graphing screen. So press the Scratchpad button to toggle over there. Delete, delete, delete 3 times. Are you sure you want to delete everything? Yes. The other thing I would probably do is reset my graphing window back to the standard window. So that is menu 4.5, zoom standard. Okay, back to my calculator screen. All right, so here I've got a function. The number of bacteria in a slow-growing culture at time t hours after 9 a.m. is given by this rule here. Okay, so I'm going to define my function first. This time I'm going to do it by defining it in the calculator screen. So menu 1.1 for define. And this function is n in terms of t. So in function notation, it is n of t. And it is equal to 54 plus 23t plus t cubed. Enter. Right, defined. Now we can use it quickly and easily. What is the initial number of bacteria at 9 a.m.? Okay, so initial number is when t equals 0. Initial when t equals 0. So we want n of 0. Now, I can do this much quicker by hand than my CAS, although it's very quick with my CAS as well. Clearly when t equals 0 here, we get 54. Now, units, so we've got 54 bacteria at 9 a.m. Okay. In my CAS, simply typing n of 0, replacing t with 0, 54. How long does it take for the initial number of bacteria to double? So initially we had 54, so therefore what this question is asking us for is how long, so we want to find t, when the number of bacteria is 2 times 54. So when the number of bacteria is 108. Okay. Now, I wouldn't expect that you need to write that line out in terms of your solution. I'm just being clear about what we're doing so that when you refer to this, you can see where things came from. So this is going to require us to solve an equation, and therefore we must write down an equation. Now, we could write out 108 equals 54 plus 23t plus t cubed, but we can also just make use of the function notation. This function's n of t, so what we're looking at here is n of t, solving n of t equal to 108. That's all we need to write down, the equation, and we can write it using the function notation. We don't need to write it out, but you must write that. This would be worth 2 marks, okay? So menu 3.1 to solve. We want to solve n of t equals 108 for t. Okay, and that happens when t equals 2, so therefore it takes 2, what's our time units? Hours. 2 hours to double. How many bacteria are there by 1 p.m.? Okay, so this is where we have to think about how time is measured. So if we go back up to the top, time is measured t hours after 9 a.m. T is in hours after 9 a.m., So we want to know how many hours after 9 a.m. is 1 p.m., okay? So 9 a.m. to 1 p.m. Is 4 hours. I think 9, 10, 11, 12, 1. Yep, get your fingers out if you need to. So it's 4 hours. So we want to know how many bacteria are there after 4 hours. So we want to know n of 4. When t equals 4, what's n? Again, over to my CAS, n of 4, 210. All right, so once the number of bacteria has reached 800, the experiment is stopped. At what time of day does this happen? Give the answer correct to the nearest minute. Okay, so a couple of things we'll need to look at here. At what time? So we're finding t. We want to know at what time, so what value of t is the bacteria 800? So that's n. Okay, so we want to know when n is 800, find the value of t. So we are solving the function n of t equal to 800. Okay, again, we can do that in our CAS. Now back over in my CAS screen over here, I don't need to, I've already solved n of t equal to something else 2 lines ago, so I'm not going to retype that whole thing. I'm going to hit up 4 times till I get here. I'm going to press enter to copy that down, and I'm simply going to adjust the 108 to be 800. Sorry, 800. So we're solving n of t equal to 800, right, and we get t equals 8.23 hours, 22676 hours. Okay, at what time of day? Not after how many hours. So we want to be able to say this is 3:56 p.m. Okay, so obviously time is measured from 9 a.m. in this problem. Okay, so 9 a.m. plus 8 hours takes us to what's that, 5 p.m. Okay, but we also want to work out how many minutes is 0.22 of an hour. So this won't be 22 or 23 minutes. This is 0.23 of 1 hour. Okay, so we want to convert that. So I actually want to work out what is 60 times 0.22676, etc. So I'm just going to do that in my calculator. I'm just going to type 60. Now, it's not easy to make use of that answer up above because you've got the 8 that you don't want. You've also got t equals, so I'm literally just going to type it. 60 times point. Now don't round off that decimal, but you don't need 1,001 decimal places, so just type in what you can see up there. So 60 times 0.22676, that will be more than sufficient to be accurate to the nearest minute. Okay, so 0.22676 of 60 minutes is 13.6 minutes. So to the nearest minute, that's 14 minutes. So this is approximately 8 hours and 14 minutes. Sorry, minutes. Okay, so then we just need to work out 9 a.m. plus 8 hours and 14 minutes. Sorry, 9 a.m. plus 8 hours and 14 minutes. So 9 a.m. plus 8 hours, again, get your fingers out if you need to. 10, 11, 12, 1, 2, 3, 4, 5. So that is going to be 5:14 p.m. So at 5:14 p.m., correct to the nearest minute, we'll have 800 bacteria in this particular dish. So category 2 examples now, so where we first need to generate the equation. All right, again, I might clear my CAS, menu 1.5. I didn't draw a graph that time, so everything's fine. Okay, a box with a square base of side length x is constructed on a wire frame of total length 60 centimeters. Okay, so we're making a box. It has a square base. Okay, so we've got this sort of thing happening. Obviously not the world's most accurate drawing, but you get the idea. So that's the wire frame, okay? Those 12 lines I've just drawn there to draw the box. That is how you would construct the box with a wire frame. Okay, so we know the box, the square base has a side length of x, so this is x by x. And in part A, it says, find the height of the box in terms of x. So again, this in terms of, this is a phrase we're going to see often. So height in terms of x means h equals, we want to find the height, h equals, but it won't be equal to a number, it will be equal to an expression involving x. Okay, so h is the height of the box. So we want to find a way, so don't assume that you're going to be able to write down h equals. But we simply need to find a way to connect h and x in an equation of some sort, and then we can worry about making h the subject of that. So the key bit of information is about our perimeter. Well, perimeter is not quite the right word for a 3D shape, but all the edges add up to 60 centimeters. So if we have a think about our diagram here, our diagram comprises 4 lengths of x on the bottom and another 4 lengths of x on the top. So we have 8 lots of x. Plus, we have 4 vertical lengths of h. So we know that 8x plus 4h is equal to 60. Okay. Now, we could take away 8x. The thing that's jumping out at me straight away is that 4 is a common factor in this equation. So let's just divide everything by 4 and tidy things up. So we've got 2x plus h equals 15. And therefore, h is equal to 15 minus 2x. So we have expressed h in terms of x. All right. Part B says show that. This is another really important instruction we want to become familiar with. Show that the volume of the box is given by this. It's really important that you understand why this is saying show that, okay? And it is because if we just, what this question really wants to ask you is find an equation for the volume in terms of x. That's what we want that question to be. The reason we don't say that is because if you can't find that equation, then you get locked out of the rest of the question. Then you can't do part C or part D, okay? So we're always going to try to avoid that happening. We're going to structure the question in a way that avoids that. So I still need to read this question as find the volume of the box in terms of x. Hint, I've given you the answer so you can check that you've got it right, okay? What that means though is if you can't do part B, you must not stop. Okay, and this is where you've got to get good at in this subject. You won't be able to answer everything in maths methods. Okay, so you need to be looking for where can I come back into this question? Where is my opportunity where, okay, I don't know how to do parts A and B and C here, but in part D they give me a rule that I then can answer the following parts after that with. Okay, so in this moment, if you couldn't do part B, you get stuck here, don't know. We're moving on to part C because you can sketch the graph of the volume function because you've been given the function. Okay, and then you can go on to part D. So I don't want to see you leaving questions blank completely once you get stopped at an earlier part. Okay, where can I come back in? All right, so show that the volume of the box is this. In my head, I'm reading find an equation for the volume of the box in terms of x. Okay. All right, so volume of a cube or a box is, length times width times height. So in this instance, volume is going to be x times h. Okay. Now we've found h. We know that is h, and that's why they got you to do that in part A. The questions are going to step you through. They're going to be helpful. Is what I just did in the last part helpful? Okay. So now we know x times 15 minus 2x, okay? And so we've pretty much got what we're trying to show. So we can see that v of x is x squared times 15 minus 2x. Careful about, don't call this v of x at the beginning, because at the beginning it's actually still got h in it as well. So it's not a function of x, it's a function of x and h. It's really important in a show that question, there is no mark for the answer. The mark in this question is going to be for the showing that. So you need to be really clear about the algebraic steps, okay? If you just write down the answer, it's not worth anything. Similarly, if you try and skip too many steps and the marker is not clear whether you actually knew what you were doing or whether you just fudged it to get to the show that answer, that won't be sufficient either. So really clear about what you're trying to do. Never in any circumstance should you be starting with what you're trying to show, okay? You can't use the answer to show that it gives you the answer, right? So you're ignoring the fact they give you the equation, you're finding an equation for the volume and ultimately ending up with the equation you're trying to show. Okay, we've got our equation. If we couldn't get our equation, it's given to us in the question. So now sketch the graph of the volume function. So again, I want you to think about this before you launch into your CAS. You know exactly what this looks like, okay? If you think about your x-intercepts here, you know that they are going to be x equals 0 and it'll be a touch or a bounce at that point. And you know it'll be 15 minus 2x equals 0. So that's going to be 2x equals 15. So x equals 15 on 2 or 7.5. And it's going to be a cut at that point. Your y-intercept is also going to be 0, or v-intercept in this instance. Okay, and so you actually already know what this graph looks like. The other phrase I want to look at here is for suitable values of x. And this is to do with something called domain. Later on, once we've done domain, the questions will ask you to draw it over a suitable domain, okay? We'll talk about that when we get to the functions and relations chapter. So suitable values of x, so we need to think about the context. So let's have a little think about this graph. So I'm just going to draw it in pencil, well, electronic pencil to start with. So we know we're going to have a touch at 0. We know we're going to get a cut at 15 on 2 or 7.5. We also know it's a negative cubic. It'll be negative x cubed. So we know it's going to look like this. Okay? So we know it's going to look like that, but let's think about suitable values of x. Our vertical axis represents volume. it doesn't make any sense to have negative volume. Okay, so this bit down here, not relevant. Our horizontal axis represents a length, represents the side length of the square base. So again, it doesn't make sense to have negative length. So therefore, the only part of this graph we're actually interested in is this part here. Sorry, let me actually follow my original pencil line. Is this part here. I want you to be careful about shape here. It's really important that there's clearly a turning point there. Okay, it's not a parabola. This is part of a cubic. X-intercepts 7.5, 0, or 15 on 2, 0, 0, 0. Optional to actually notate that. Now it does ask you to label all intercepts and turning points. So we do need to label this turning point. So we don't have the algebraic skills to do that yet, but we can find that point in our CAS. So again, you might define the function. I probably wouldn't bother here. There's not much more to come. Once I've got my graph, I'll be able to answer part D. I'm just going to go straight over and draw the graph. Pressing tab if you can't see the entry line. So my equation is x squared times 15 minus 2x. We can see our cubic. We've already thought about what it looks like. It's not a surprise what we're seeing here. The window is clearly way out. Okay, we're seeing the x-intercepts. We can see it's very, very steep. Now I'm going to have trouble here selecting that maximum y value because my graph's going to get in the way. You might find it hard to be able to actually click on this number here. If that's the case, okay, you can do it through the menus. Menu for 1 for window settings and adjust that maximum y value. Okay, so y max a lot bigger than 6. I'll go with 50, but I think we probably need to go into the hundreds. Yeah, okay. So again, it's just a bit of a trial and error, really. Just keep making it bigger till you get where you want. I think let's try 300 and see. Okay, way too much. All right, go with 150. Okay, good. You can adjust the horizontal axis as well, but we're just interested in the turning point here. So menu, 6 for analyze graph, we've got a maximum turning point. Now, unlike when we did the parabola before, we completed the square in the calculator screen to find the turning point, but that's only for quadratics. This isn't a quadratic, it's a cubic, and we don't yet have any algebraic tools for finding the turning points of the cubics. So we have to do it in the graphing screen, and we'll have to therefore give decimal answers, although the fact this question doesn't tell me to round leads me to believe this is probably going to be a nice exact point. Okay, somewhere to the left, somewhere to the right. Now, again, I just want to check 5, my CAS is set to float 3. So if 5 was 5.369, whatever, it would show me 2 decimal places. So I'm confident 5 is right. This is 3 float, I'm seeing 3 digits here. So I might just check that there isn't any more. Okay, no, it's exactly 5, 125. So I'll label that on my graph. Okay, and then we're good to go. So we are ignoring the scribbled out grey bits. It's too difficult for me to work out the eraser without it erasing the whole stroke. Oh, there we go. Doesn't matter. Great. Okay, so there's my graph. I would like to make that turning point at 0, 0 a little more pronounced than it is, just as a note. Okay, state the maximum volume of the box and give the dimensions of the box that produce this maximum volume. Okay, so here is our maximum volume. So it's clearly the y value of the turning point, and that happens when x equals 5. Okay, so our maximum value happens when x equals 5. So maximum volume is 125. Now, what were the units in this original problem? Let's go back up the top here. Centimeters. So 125 cubic centimeters. It also asks us for the dimensions. The dimensions of a box are length and width and height. So we actually also need to calculate h. So we know that the maximum the maximum volume happens when x equals 5. So the base of the box will be 5 by 5. But when x equals 5, we need to work out what h is. And when x equals 5, h is going to be 15 minus 2 times 5. So that's 15 minus 10. So h is also 5. Okay. So in this instance, maximum volume is 125 centimeters cubed. And then our dimensions are going to be, so the dimensions x by h, okay? So again, noting that h was 15 minus 2x, so that's 15 minus 2 times 5, 15 minus 10, so 5. So maximum dimensions are 5 centimeters by 5 centimeters by 5 centimeters. Sorry, not maximum dimensions, dimensions that give maximum volume. So in this instance, we get the maximum volume when we have a cube. That's actually true all the time. So if you're maximizing the area of a rectangle, it would be a square. But then sometimes you have extra conditions that mean that that's not quite true, that you have to actually skew what's happening. Okay, again, we've reached a sort of 20-minute mark here, so I'm going to stop this video here and I'm going to record a third video with the remaining application questions.